Hello. In this video, we're going to learn how to solve this nice Olympiad style equation. So we have x power 7 plus x power 5 plus x power 3 over x power 6 plus x power 5 plus x power 4 is equal to 81 over 27. So the first thing we're going to do is identify the common factor both in the numerator and the denominator of the left hand side. So for the numerator, the common factor is x power 3. So we're going to have x power 3 outside the bracket, so that in the bracket you have 7 minus 3, that is 4. So we have x power 4 plus 5 minus 3, that is 2. So we have x power 2, and 3 minus 3 is 0. So we have x power 1, x power 0, which is just 1. And then for the denominator, we have the common factor being x power 4. So we have inside the bracket, we have x power 2 plus x power 1 plus 1. So that is what we have in the denominator. And then 81 divided by 27 is 3. So the next step is to cancel or simplify the two x's that are outside the bracket. So x power 3 goes here once, it goes here x times. So it means what we are left with in the numerator is just x power 4. So you should have x power 4 plus x power 2 plus 1. But in the denominator, we have x into x power 2 plus x plus 1. And that's equal to 3. So the next thing we're going to do is make the numerator a perfect square. We can do that by introducing other terms without changing the value. So we can add 0 to the numerator in this manner. If we add 0 to a number, it does not make a difference. But we're going to write that 0 as x squared minus x squared. Remember, x squared minus x squared is still 0. So when we add this to the numerator with the aim of making it a perfect square, there is no change in the value. So let us apply that. So we can rewrite the numerator as x power 4 plus x power 2 plus 1 plus 0, which we write as x squared minus x squared. And then this is over x into x power 2 plus x plus 1, and that's equal to 3. So in the numerator, we can combine two of those. We can take this one, we can take this x squared and this x squared, so that we have 2x squared. But we just leave that on the way it is. So if you write our equation in that method, we're going to have x power 4 plus 2x squared plus 1, and now minus x squared. And that is over x into x squared plus x plus 1 is equal to 3. So again, we can rearrange, or we can modify the numerator. We can write x power 4 as x squared squared using the third law of indices. So that is plus 2x power 2 plus 1, and we can write 1 as a 1 squared, and minus x squared, and we have over x into x squared plus x plus 1, and that's still equal to 3. So if you look at the numerator, you'll realize that the first terms here, that is, if you look at this portion, it looks like one of the quadratic identities. That is, we have a squared plus 2ab plus b squared. That is, it looks like a squared plus 2ab plus b squared, and this normally translates to a plus b squared. So if you look at that in this method, then we can rewrite that numerator as x squared plus 1 squared if we use these quadratic identities. And then this x squared is still left there, so we say minus x squared. And then the denominator is still the way it was. That is x into x squared plus, that is x squared plus x plus 1. And that's equal to 3. Again, if you look at the numerator, it is a difference of squares. And remember from the quadratic identities that a difference of squares, that is a squared minus b squared, is the same as a plus b times a minus b. So we can use that relationship in the numerator. So we can rewrite the numerator as x squared plus 1 minus, so b in this case is x there. So we have minus x like that times this other one, that is x squared plus 1 plus x. That is if we apply this quadratic identity. Then that is over, and the numerator is still the same way it was. So we still have x into x squared plus x plus 1. And this is still equal to 3. So if we rearrange the terms in the numerator, so that we have x squared, instead of this we write minus x, then plus 1 times, the second one will be x squared plus x plus 1 over x into x squared plus x plus 1 is equal to 3. So you can see that some terms look alike in the numerator and the denominator. So if you look at this, x squared plus x plus 1 and x squared plus x plus 1 will cancel. So that what we are left with in the numerator, we have x squared minus x plus 1, and in the denominator we only have x, and that is still equal to 3. So the next thing is just to cross multiply. Put this is 3 over 1. When you cross multiply, we're going to have x squared minus x plus 1 is equal to 3x. Then we bring 3 to the left hand side, so we have x squared minus x minus 3x plus 1 is equal to 0. So if we condense this, we realize that we have a quadratic equation, that is x squared minus x minus 3x is minus 4 plus 1 is equal to 0. So this is a quadratic equation that we can use any of the methods to solve. So let us go for the simplest one, that is using the quadratic formula. It is given by x is equal to minus b plus or minus the root of b squared minus 4ac, and that is over 2a. So let us identify a, b, and c in our quadratic equation. So a, that is the coefficient of x squared, in this case is 1. B, the coefficient of x is negative 4. And c, the constant term is 1. So if we substitute these values into our formula, minus b will be minus into bracket minus 4 plus, under the root we have b squared, that is minus 4 squared, minus 4 into a into c, and that is over 2a, that is 2 into 1. So we can simplify this. So we have minus minus, that will be plus. So we have positive 4 positive 4 plus or minus, under the root we have negative 4 squared, that is 16, and you have minus 4 times 1 times 1, that is just minus 4, and that is over 2 times 1, which is just 2. Then now we can simplify. We have 4 plus or minus the root of 16 minus 4, that is 12, over 2. So that is the same as 4 plus or minus the root of 4 times 3, and that is still over 2. So we can get the square root of 4 as 2. So we can write these as 4 plus or minus the root of 4 is 2, and then root 3 over 2. So we can see that 2 is a common factor in the numerator. So you can have 2 into 2 plus or minus root 3, and that is over 2. So 2 and 2 will cancel. So we are left with x being equal to 2 plus or minus root 3. So this has got two solutions. There's one when we consider the positive, and there's one when we consider the negative. So x can be seen as 2 plus, that is if we take the positive sign, plus root 3, or x can also be seen as 2 minus root 3, that is if we take the negative sign. Thank you for watching. Please remember to subscribe.